Task 10. Trigonometric Identities. R.D.sharma. Chapter 11. Prove that. First question. 1 minus cos square a in bracket close cosec square a is equal to 1. First we know that 1 minus cos square a is equal to sin square a. Then cosec square a is equal to 1 upon sin square a. So we can write here sin square a in place of 1 minus cos square a and into 1 upon sin square a. Sin square a divided by sin square a give to 1. So it is equal to right hand side. It's equal to 1. Right hand side. Question number 2. Prove that 1 plus cot square a bracket close sin square a is equal to 1. Left hand side and it is right hand side 1. We need to prove. First we know that 1 plus cot square a is equal to cosec square a. So in case of 1 plus cot square a, we can write cosec square a bracket close into sin square a and cosec square a is equal to 1 upon sin square a. So we can write 1 upon sin square a into sin square a. Sin square divided by sin square a in one time. So it is 1. It is equal to right hand side. Question number 3. Tan square theta into cos square theta is equal to 1 minus cos square theta. So left hand side it is tan square theta plus into cos square theta and right hand side 1 minus cos square theta. Tan square theta is equal to sin square theta upon cos square theta. So in place of tan square theta we can write sin square theta upon cos square theta into cos square theta. So cos square theta divided by cos square theta we get sin square theta, and we know that sin square theta is equal to 1 minus cos square theta. So it is our answer. This is equal to right hand side. Question number 4. Cos theta under root 1 minus cos square theta is equal to 1. Cos theta 1 we can write sin square theta. So it's equal to 1. Cosec theta is equal to into sin theta, cos theta into sin theta means 1 upon sin theta into sin theta. Sin theta into sin theta is equal to 1. So left hand side is equal to right hand side. Sec square theta minus 1 into sec square theta minus 1 cos is equal to 1. Sec square theta minus 1 we can write tan square theta, and in place of cos square theta minus 1 we can write cot square theta. Now tan square theta into 1 upon cot square theta we can write 1 upon tan square theta divided by tan square theta to tan square theta is give 1, which is equal to right hand side. Tan theta plus 1 upon tan theta is equal to sec theta into cos theta. First we will take left hand side and this is right hand side. We can write tan theta. In place of tan theta we can write sin theta upon cos theta plus 1 upon sin theta upon cos theta. Cos theta goes to upside, and if we take LCM of it we get here cos theta into sin theta cos theta divided by cos theta, we get here sin square theta plus cos square theta. We know that sin square theta plus cos square theta is equal to 1 upon cos theta into sin theta. Now we can write 1 upon cos theta into 1 upon sin theta. 1 upon cos theta is equal to sec theta. We can write in place of 1 upon cos theta is equal to sec theta, and in place of 1 upon sin theta we can write cosec theta. So it is equal to right hand side. Question number 7. Cos theta upon 1 minus sin theta is equal to 1 plus sin theta upon cos theta. We can write here left hand side and this is the right hand side. We can rationalize it like cos theta upon 1 minus sin theta. We can multiply it the opposite of denominator. So now it become cos theta in bracket 1 plus sin theta, and it 1 minus sin theta into 1 plus sin theta is equal to 1 minus sin square theta. We can again write cos theta in bracket 1 plus sin theta, and in place of 1 minus sin square theta we can write cos square theta. Cos theta can be divided by cos theta. We can write cos theta 1 plus sin theta upon cos theta into cos theta. 1 cos theta has been divided by cos theta. We get here 1 plus sin theta upon cos theta, which is equal to right hand side. So it is our answer. In question number 8, cos theta upon 1 plus sin theta is equal to 1 minus sin theta upon cos theta. So first we left hand side and this is right hand side. We can rationalize cos theta upon 1 plus sin theta by multiplying it in the opposite of its denominator, 1 minus sin theta, and 1 minus sin theta again. We get here cos theta in bracket 1 minus sin theta, and here 1 plus sin theta, 1 minus sin square theta. So cos theta multiplied by cos theta 1 minus sin theta, and 1 minus sin square theta become cos square theta. It is deducted. We get here 1 minus sin theta and cos theta, which is equal to right hand side. Question number 9. Cos square theta plus 1 upon cos square theta is equal to 1. It is the left hand side and it is the right hand side. It is 1. Cos square theta we can write 1 plus cot square theta is equal to cosec square theta. So we can write cos square a plus 1 upon cosec square a. So we can write again cos square a plus 1 upon cos square a. Cosec square a means sin square a, and the value of cos square a plus sin square is equal to 1, which is equal to right hand side. Question number 10. Sin square a plus 1 upon 1 plus tan square is equal to 1. Left hand side it is sin square a plus 1 plus tan square a. We can write in place of sec square a. So we can write 1 plus tan square a is equal to sec square a, and we know that sec square a is equal to 1 upon cos square a, and so cos square is equal to 1 upon sec square a. So sin square a plus cos square a, which is equal to 1. It is equal to right hand side. Question number 10. 1 plus under root 1 minus cos theta upon 1 minus 1 plus cos theta is equal to cosec theta minus cot theta. So we can rationalize it by multiplied. First we differentiate left hand side and right hand side. So we can write 1 minus cos theta upon 1 plus cos theta is equal into 1 opposite of it 1 minus cos theta. We can write in place of root 1 minus sin cos theta whole square upon 1 minus cos square theta. So we can write here 1 minus cos theta whole square means sin square theta, and 1 minus cos square theta is equal to sin square theta, and this become 1 minus cos theta whole square. 1 minus cos theta because of it is sign change, same sign we will multiply to it. So it becomes 1 minus cos theta, 1 minus cos theta the whole square. Now this become 1 minus cos theta upon sin theta. We can write it 1 upon sin theta minus cos theta upon sin theta. 1 upon sin theta means cosec theta, and cos theta upon sin theta means cot theta. So we get here the right hand side value, which is question number 12. 1 minus cos theta upon sin theta is equal to sin theta upon 1 plus cos theta. So if we write left hand side and it is right hand side, so we can rationalize it by writing 1 minus cos theta upon sin theta into opposite of it 1 plus cos theta upon and 1 plus cos theta. So we can write here 1 minus cos square theta upon sin theta in bracket 1 plus cos theta. So we can write here sin square theta and sin theta in bracket 1 plus cos theta. Now 1 sin theta is divided by sin theta, so it becomes sin theta into sin theta and upon sin theta 1 plus cos theta. Sin theta divided by sin theta, we get here sin theta upon 1 plus cos theta, so it become equal to right hand side. Question number 13. Sin theta upon 1 minus cos theta is equal to cosec theta plus cot theta. So we can write left hand side, and sin theta upon 1 minus cos theta we can rationalize it by multiply it by opposite of denominator 1 plus cos theta. We get here sin theta in bracket 1 plus cos theta and 1 minus cos theta cos 1 minus cos square theta. We get here sin theta 1 plus cos theta upon sin square theta. 1 sin theta divided by sin theta, so we get here 1 plus cos theta upon sin theta, sin theta into sin theta we can write. So now we get sin 1 plus cos theta upon sin theta, which is we can write it 1 upon sin theta plus cos theta upon sin theta. upon sin theta means cosec theta, and plus cos theta upon sin theta means cot theta, which is equal to right hand side. Now question number 14. 1 minus sin theta upon 1 plus sin theta is equal to sec theta minus tan theta whole square. We can rationalize it by multiply up opposite of denominator, 1 minus sin theta. So we can write here 1 minus sin theta whole square, 1 minus sin theta whole square, and one time write 1 minus sin square theta, 1 minus sin theta whole square. We can write 1 minus sin theta whole square upon cos square theta. So we can now write 1 minus sin theta upon cos theta whole square. Now it become 1 upon cos theta minus sin theta upon cos theta all whole square, means 1 minus, we can write 1 minus cos theta means what, sec theta, minus sin theta upon cos theta means tan theta whole square, which is equal to right hand side. Now question number 15. 1 plus cot square theta in bracket tan theta upon sec square theta is equal to cot theta. Because of 1 plus cot square theta is equal to cosec square theta. So we can write here cosec square theta into sin theta upon cos theta and upon sec square theta, Now we can write in place of cos square theta 1 upon sin square theta into sin theta upon cos theta upon, in place of sec square theta we can write 1 upon cos square theta. Now sin divided by sin theta, we get here 1 upon sin theta into cos theta and by 1 upon cos theta into cos theta. So we can write it 1 upon sin theta into cos theta into cos theta into cos theta, it go upside, upon 1. So we write here divided by cos theta upon sin theta, which is equal to cot theta, which is equal to right hand side. Now question number 16. Tan square theta minus sin square theta is equal to tan square theta into sin square theta. First we write left hand side and right hand side. Tan square theta is equal to sin square theta upon cos square theta minus sin square theta by 1. Take their LCM, it is cos square theta. We can write sin square theta minus cos square theta into sin square theta. Now we can, if we take comma sin square theta, we get here 1 minus cos square theta upon cos square theta. So we can write sin square theta into sin square theta, in place of 1 minus cos square theta we can write sin square theta upon cos square theta. Now sin square theta upon cos square theta means tan square theta means tan square theta n into sin square theta, which is equal to right hand side. Now question number 17. Cos theta plus sin theta, in other brackets cos theta minus sin theta is equal to cot square theta plus cos square theta. First left hand side, we can write left hand side cos theta, which we can represent a plus b, a minus b is equal to a square minus b square, cos theta cos square theta minus sin square theta we can write in place of this. So we can write here cos square theta means 1 minus 1 plus cot square theta, and in place of sin square theta we can write 1 minus cos square theta. After opening, 1 plus cot square theta minus 1 plus cos square theta cos square theta. Now 1 divided by minus 1, we get cot square theta plus cos square theta, which is equal to right hand side. Now question number 18. Sec theta plus cos theta and second bracket sec theta minus cos theta is equal to tan square theta plus sin square theta. It is at left hand side. So first we write sec square theta minus cos square theta. In place of both, we can write 1 plus cot, not cot, tan, 1 plus tan square theta, 1 plus tan square theta, and minus 1 minus sin square theta. 1 plus tan square theta minus 1 plus sin square theta. 1 is divided by 1, we get here tan square theta plus sin square theta, which is equal to right hand side. Now question number 19. Sec theta in bracket 1 minus sin theta bracket close bracket sec theta plus tan theta is equal to 1, and sec a multiplies 1 to sec a minus sec a into sin a, in second bracket sec a plus tan a. So we can write sec a minus 1 upon cos a into sin a, and here we can write sec a plus tan. Now we can interchange sec a minus sin a upon cos a bracket close sec a plus tan. Now we can write in place of sin a upon cos a tan a. Now it becomes form of a square minus b square. So we can write here sec plus b, a minus b. Now we can write sec square a minus tan square a, which is equal to 1, which is right hand side, equal to right hand side. Now question number 20. Cosec a minus sin a is in bracket sec a minus cos a, and third bracket is tan a plus cot a is equal to 1. We can write in place of cosec a 1 upon sin a minus sin a. In second bracket we can write 1 upon cos a minus cos a upon, in place of tan a we can write sin a upon cos a plus cos a upon sin a in place of cot a. Now if you take LCM, we get here sin a, and upside 1 minus sin square a. Same like that, take LCM, it is cos a, we get here 1 minus cos square a. And here if we take LCM, we get here cos a into sin a, and upside sin square a plus cos square a. Now 1 minus sin square a means cos square a upon sin square sin a, and here 1 minus cos square means sin square a upon cos a. Here since sin square a plus cos square is equal to 1, now if we divide cos a divided by cos a, sin a, again sin a, and cos a divided to cos a, so we get here nothing, it is equal to 1, because cos square a upside 2 times and downside it is 2 times cos a, and sin a downside 2 time and upside 2 time, so which is equal to 1. All will be divided by each other, so it is right hand side we get here all are deleted, so we can write here 1. Now question number 21. It is 1 plus tan square theta, in another bracket 1 plus 1 minus sin theta, and third 1 plus sin theta is equal to 1. So we can write 1 plus tan square theta, 1 minus sin theta, and 1 plus sin theta become 1 minus sin square theta. Now 1 plus tan square theta we can write sec square theta, and 1 in place of 1 minus sin square theta we can write cos square theta.